In the darkness beyond Neptune, something 10 times the size of Earth is hiding and pulling invisible strings in our solar system. We know it exists because distant worlds are dancing to its gravitational melody, tilting and clustering in ways that should be impossible. We will discover the mathematical engineering work that revealed this cosmic imitation master. We will examine the desperate telescope searches scanning 20,000 square degrees of empty space and uncover why this discovery could rewrite the story of how planets form. If you're ready to search for the most complex world in our solar system, hit the like button and subscribe for more cosmic mysteries. Let's continue exploring together. Cosmic flashers. For cosmic flashers 4 billion miles from the Sun, there is a serious problem with the outer solar system. In the Kuiper Belt, where chunks of ice and rock drift in the cosmic deep, 6 massive objects are behaving like cosmic rebels. These are not ordinary space rocks. Each one is bigger than a mountain, desolate like streams. Some are even bigger than countries, and they're all doing something that should be impossible. Imagine a classroom where 6 students are sitting. Now imagine walking in to find all 6 desks turned at exactly the same weird angle, all facing the same strange direction. You would immediately realize that something made them move that way. Someone or something arranged them. This is exactly what astronomers discovered when they studied these distant worlds. Objects like Sedna, Biden, and the mysteriously named 2012 VP113. Each one follows an orbit so stretched and tilted that it resembles a cosmic egg lying sideways. But here's the crucial point. They are all tilted in almost exactly the same direction. The probability of this happening by chance is the same as flipping a coin 20 times in a row and getting tails every time. We're talking about a 1 in 64 chance. This is not coincidence. This could be evidence. These objects are sustaining their existence so far from the Sun that it takes more than 6 hours for light to reach them. There, the Sun looks like just another bright star. No heat, no warmth, just the endless cold of deep space. Yet something seems to be controlling their paths invisibly. Think of a shepherd herding sheep. You can't see the shepherd, but you watch all the sheep moving in formation, responding to the same invisible commands. The sheep are these distant worlds. The shepherd is something we've never seen. What makes this even more strange is how these objects move. Most things in the solar system orbit the Sun like cars on a racetrack, staying roughly in the same flat plane. But these flashers are tilted up and away from everything else, as if they're following rules written by a different cosmic order. Scientists call this the clustering problem. When you plot these orbits on a map, they all point to the same region of space, as if there's something massive there. Something with enough gravitational power to move around worlds the size of a country from billions of miles away. For decades, astronomers assumed the outer solar system was mostly empty space, with a few scattered ice balls. We thought we had mapped the major players, the 4 gas giants, Pluto, and some cosmic debris. We were wrong. These orbital flashers are like messengers from the darkness, telling us that our solar system has been hiding a secret for 4.5 billion years. But the mystery is just becoming clear. Mathematical detectives. 2 astronomers from Caltech looked at their computer screens and saw the impossible staring back at them. Mike Brown and Konstantin Batygin weren't looking at the computer to search for a new planet that day in January 2015. Another team had claimed that a massive world was lurking beyond Neptune, and Brown was determined to prove them wrong. After all, he was the one who helped kill Pluto's planet status. He knew how to destroy planetary dreams with cold, hard mathematics. But the numbers wouldn't cooperate. Every calculation pointed to the same shocking conclusion. Something massive was hiding in the darkness. Think of it like a detective discovering footprints at a crime scene. You can't see the person who made them, but the prints tell you everything: how heavy they were, which direction they walked, even their shoe size. Brown and Batigan were cosmic detectives, and the footprints were gravitational. They fed every known orbit from the outer solar system into their computers. Objects like Sedna, with its egg-shaped path that takes 11,000 years to complete. Worlds like 2007 TG422 that swing so far out they practically leave the solar system entirely. Each orbit was a clue. Computer simulations showed something that made their hearts race. If you removed everything beyond Neptune and let the solar system evolve naturally, those rebel objects should scatter randomly across the sky. Their orbits should point in every direction like spokes on a broken wheel. But they don't. They cluster together like iron filings around a hidden magnet. Brown and Batigan tried everything to make the clustering disappear. They adjusted their models. They questioned their data. They ran the simulations thousands of times with different starting conditions. The result was always the same. These distant worlds were being herded by something massive. The mathematics required a world at least 10 times heavier than Earth, orbiting somewhere between 200 and 700 times farther from the Sun than we are. That's so distant that it would take this hidden giant between 10,000 and 20,000 years to complete a single orbit. Think of trying to find a black cat in a coal mine at midnight. Now imagine that coal mine is bigger than the entire United States, and you're searching with a flashlight. That's the challenge facing astronomers trying to spot Planet 9. Brown and Batigan published their findings with a confidence that shocked the scientific community. They weren't suggesting Planet 9 might exist, they were declaring it must exist. The evidence was written in the orbital language of worlds we could see, pointing toward a cosmic giant we couldn't. But proving something exists and actually finding it are completely different battles. The invisible puppet master. Imagine trying to control a marble from 3 miles away using only the power of your thoughts. That's essentially what Planet 9 is doing to objects in the outer solar system, except the distances are measured in billions of miles, and the marbles are worlds larger than continents. Gravity is a deceptively gentle force. Right now, you're experiencing the full gravitational pull of an entire planet, Earth's entire gravitational pull, and it's just barely enough to keep your feet on the ground. A gentle jump can temporarily overcome it. Yet somehow, Planet 9 is reaching across interplanetary space to influence worlds with the precision of a cosmic choreographer. The key lies in what scientists call orbital resonance. Think of a parent pushing a child on a swing. Push at the wrong moment and nothing happens. Push at exactly the right moment again and again, and small forces turn into powerful motion. Planet 9 doesn't need to be close to its targets, it just needs to be patient. Every time one of those distant objects completes its orbit around the Sun, Planet 9 gives it a small gravitational nudge, just a whisper of force, barely perceptible. But over millions of years, these whispers turned into commands that reshape entire orbital paths. Consider the object called Sedna. It swings out to 900 times Earth's distance from the Sun. At that distance, the Sun appears smaller than a pinhead held at arm's length. At that distance, Sedna should be free from any planetary influence. It should go wherever cosmic chance takes it. Instead, it follows a precise elliptical highway as if it's riding on invisible rails. Planet 9 acts like a gravitational lighthouse, sweeping its influence across the darkness. Objects that enter its domain get caught in what astronomers call secular resonance, a long-term gravitational relationship that slowly but steadily alters their orbits. The mathematics is both beautiful and terrifying. Planet Nine's gravity doesn't need to be strong, it just needs to be persistent. Like water carving the Grand Canyon, small forces applied over geological time can move mountains, or in this case, worlds. But here's what makes this truly mind-bending. Planet Nine isn't just randomly controlling these objects, it's organizing them into specific patterns, creating something like a cosmic filing system. Objects with similar orbital characteristics get grouped together as if they're responding to the same gravitational filing clerk. This isn't some chaotic force randomly disturbing the outer solar system. This is precision engineering on a scale above anything humans have ever attempted. Planet Nine has been playing cosmic billiards for billions of years, and every shot has been calculated with mathematical perfection. The question that keeps astronomers awake at night is simple yet profound. What kind of world possesses this level of gravitational authority? The greatest hunt. Finding Planet Nine is like searching for a single black grain of rice scattered somewhere across the entire surface of North America. The moment Brown and Badigan published their prediction, observatories around the world began the most ambitious treasure hunt in astronomical history, each hoping to make the discovery of the century by pointing their most powerful telescopes toward the night sky. There were teams in Chile, Hawaii, California, and Australia, but Planet Nine had every advantage. It's probably darker than charcoal, reflecting less than 5% of the sunlight that reaches it. The sun, from Planet Nine's perspective, appears 27 times dimmer than it does to us. This means Planet Nine receives less than 1/700th of the solar energy that Earth gets, essentially a frozen world drifting through permanent twilight. Think of trying to spot a black basketball floating in a swimming pool, but the pool is the size of Texas and you're searching with binoculars from an airplane. Now think of the basketball moving in slow motion, and you're getting close to the challenge facing astronomers searching for Planet Nine. The search zone covers 20,000 square degrees of sky. To put that in perspective, the full moon covers about half a degree. This means astronomers need to examine an area equivalent to 40,000 full moons, looking for something that might be 1,000,000 times fainter than the faintest stars visible to the naked eye. Modern telescopes can capture incredibly detailed images, but they see the universe one small patch at a time. The Subaru telescope in Hawaii, one of the Planet Nine hunters, captures an area about the size of 4 full moons in each photograph. This means it would take 10,000 individual images to cover the entire search zone just once. But here's the cruel reality. Planets move. By the time you finish photographing the entire search area, Planet Nine has shifted to a new position. The motion is glacially slow. Planet Nine probably moves less than 2 arc minutes per year. That's about 1/15th the width of the full moon. But when dealing with distances measured in billions of miles, even that tiny motion means the planet could be hiding in a completely different part of the sky than calculations predict. Teams developed new strategies. Instead of looking for Planet Nine directly, they started looking for its motion. They would photograph the same patch of sky multiple times over several months, then use computers to identify anything that moved between images. Stars stay put. Galaxies don't move. But planets do. Computers flagged millions of moving objects. Most turned out to be asteroids, closer and much brighter than Planet Nine. Others were cosmic rays hitting the telescope's detector, creating false signals that look like moving points of light. Each promising candidate required weeks of follow-up observations to confirm or rule out. Teams would watch potential Planet Nine candidates for months, tracking their movements, measuring their brightness, hoping for the discovery that would rewrite astronomy textbooks. But the darkness beyond Neptune kept its unknowns, and the most elusive world in our solar system remained hidden. Conspiracy theory. 6 worlds, billions of miles apart, all telling the same impossible things. When astronomers first noticed that distant objects in the outer solar system were clustering together, They assumed it was a statistical fluke. Space is unknown, and coincidences happen. But as more objects were discovered, what appeared became undeniable. These weren't random coincidences. This was proof of a conspiracy. The smoking gun lies in something called the argument of perihelion. That's the technical term for the point where each object comes closest to the sun during its orbit. Think of it as the bottom of a cosmic roller coaster, the point where each world reaches maximum speed before climbing back into the outer darkness. For 6 major objects beyond Neptune, these closest approach points all cluster within about 60 degrees of each other in the sky. Think of a clock face. If one object reaches its closest point to the sun at 12 o'clock, the others all cluster between 10 and 2. The probability of this happening randomly is the same as winning the lottery twice in the same week, so it seems impossible. But the conspiracy goes deeper. These objects don't just cluster in one direction. They're also tilted away from the main plane of the solar system by the same amounts. Most planets orbit the sun like cars on a flat racetrack, staying within a few degrees of the same level. But these distant rebels are tilted upward by 15 to 30 degrees, as if they're all following the same tilted highway into space. The object called Biden provides a perfect example. It's about the size of Pluto, and it takes 550 years to complete one orbit around a sun. At its farthest point, Biden ventures out to nearly 150 times Earth's distance from the sun. That's so far that radio signals would take more than 20 hours to reach it. Yet Biden's orbit is perfectly aligned with the other conspirators. Its orbital plane, its tilt, its direction of motion, everything matches the pattern predicted by Planet Nine's gravitational influence. Then there's 2012 VP113, discovered by the same team that found Biden. This object follows an even more extreme path, swinging out to more than 200 times Earth's distance from the sun. Its orbit takes 4,000 years to complete, yet it too follows the same mysterious alignment. The most compelling evidence comes from computer simulations. When astronomers remove Planet 9 from their models and let the solar system evolve naturally, the clustering disappears within a few million years. Objects scatter randomly across the sky, following the chaotic paths you'd expect from worlds influenced only by the sun and known planets. But when they add Planet 9 back into the simulation, a world 10 times Earth's mass orbiting at the predicted distance, the clustering reappears like magic. The scattered objects gradually migrate into the same tilted, aligned configuration we observe today. The conspiracy extends beyond just orbital alignment. These objects also show similar colors and compositions, suggesting they might have formed in the same region of the solar system before being scattered by Planet 9's gravitational influence. 6 witnesses, all testifying to the presence of something massive lurking in the cosmic shadows. But the mathematical evidence was about to become even more convincing. Statistical evidence. The numbers don't lie, and they're screaming that something massive is pulling the strings. When astronomers want to prove something exists, they turn to statistics, the cold, objective language of probability that strips away wishes and reveals mathematical truth. In the case of Planet 9, the statistics are so compelling they border on the undeniable. The clustering of distant objects isn't just unusual, it's mathematically impossible without an external force. Imagine flipping 6 coins and having them all land on tails. This would surprise you, but it happens about once in every 64 tries. Now, imagine flipping those same 6 coins 100 times in a row and they land on tails every time. That's not luck anymore. That's evidence of loaded coins. The orbital alignment of these distant worlds represents odds far worse than loaded coins. When astronomer Scott Shepard calculated the probability of 6 objects randomly clustering the way they do, he found a chance of about 1 in 14,000. But that was just the beginning. As more objects were discovered, the evidence became overwhelming. The object called 2014 SR339 follows the same tilted, elongated orbit as the others. So does 2013 RF98. Each new discovery that fits the pattern makes random chance increasingly less believable. Think of it like finding a crime scene where 6 witnesses all give identical testimony down to the smallest details. Either they're all lying in perfect coordination, or they're all telling the truth about something they actually witnessed. Statistical analysis goes beyond simple clustering. These objects also show what astronomers call longitude of perihelion alignment. That's the direction in space where each object makes its closest approach to the Sun. For all 6 major objects, this direction points toward the same narrow wedge of sky. But the mystery gets even stranger. The objects aren't just aligned, they're anti-aligned with Planet 9's predicted orbit. They cluster on the opposite side of the solar system from where Planet 9 should be, as if they're running away from something, all fleeing in the same direction. Computer simulations explain this perfectly. Planet 9's gravity doesn't just attract these objects, it shepherds them into stable orbital configurations that keep them safely away from close encounters, like a cosmic traffic cop directing the flow of distant worlds to prevent collisions. The mathematics becomes even more convincing when you consider what astronomers call the Kozai mechanism. This describes how a distant, massive object can gradually change the orbits of smaller objects, tilting them and stretching them into the exact configurations we observe. Planet 9's influence operates on timescales that dwarf human history. The gravitational shepherding takes millions of years to guide these distant objects into their current alignment. The clustering we see today is the result of patient gravitational sculpting that began when Earth was still a molten ball of rock. Recent discoveries have only strengthened the case. Objects like Goblin and Far Out both show orbital characteristics consistent with Planet 9's influence. Each new addition to the family of distant objects provides another data point in the statistical case for a hidden 9th planet. The mathematical evidence has reached a tipping point where denying Planet 9's existence requires explaining away coincidences that strain credibility. But identifying the puppet master is only half the mystery. Understanding what kind of world could wield such power is the other half. What is Planet 9? Planet 9 is hiding not only its location, but also its identity. The gravitational evidence tells us that something massive is lurking beyond Neptune, but determining exactly what that something is requires detective work that pushes the boundaries of planetary science. Is Planet 9 a super-Earth, a rocky world built like our planet but scaled up to massive proportions? Or is it a smaller version of the ice giants, with thick atmospheres and exotic compositions, a mini Neptune? The mass calculation is relatively straightforward. To shepherd distant objects the way Planet 9 does, it must weigh at least 5 times more than Earth, probably closer to 10 times more. This puts it squarely in the category that astronomers call super-Earths, worlds bigger than our planet but more minimalist than Neptune. But mass alone doesn't tell the whole story. A world 10 times Earth's mass could be a dense, rocky super-Earth about twice our planet's diameter, or it could be a fluffy mini Neptune, 3 times Earth size, filled with water, methane, and hydrogen. The difference matters because it tells us where Planet 9 came from and how it got to its current location. Think of it like trying to identify a person from their shadow. You can tell they're tall, but you can't tell if they're a basketball player or just someone wearing platform shoes. Planet 9's gravitational shadow reveals its mass, but not its composition. The rocky super-Earth scenario depicts Planet 9 as a world built like Earth, but dramatically scaled up. Its surface would be a frozen wasteland of rocks and ice, with temperatures hovering around -240 degrees Celsius. Any atmosphere would be frozen solid on the surface. This would be a world where the atmosphere itself outweighs all the continents on Earth. The mini-Neptune scenario is much more exotic. This version of Planet 9 would be wrapped in a thick envelope of hydrogen and helium, perhaps with deeper layers of water and ammonia ice. Its core might be rocky, but most of its bulk would be gas and ice. This is a world where the atmosphere itself outweighs all the continents on Earth. An interstellar thief? Planet 9 might be an alien world that our sun stole from another star 4.5 billion years ago. The solar system wasn't the lonely island it is today. The sun was born in a stellar nursery where hundreds of young stars formed from the same giant cloud of gas and dust. In that cosmic nursery center, planetary theft was not just possible, it was inevitable. Imagine a cosmic game of musical chairs, but instead of chairs, stars are stealing planets from each other. Young stars in dense clusters regularly pass within a few hundred times Earth's distance from each other. This might sound far, but in cosmic terms, it's close enough for gravitational hijacking. Computer simulations of these early stellar encounters reveal something shocking. When two star systems pass close together, their outer planets get tossed around like cosmic ping-pong balls. Some planets get ejected entirely, becoming rogue worlds that drift alone through interstellar space. Others get captured by the passing star, becoming permanent members of a new stellar family. The mathematics works perfectly for Planet 9, a world with 10 times Earth's mass, originally orbiting another star at a distance similar to Jupiter's orbit, could be captured by our sun during a close stellar encounter. The gravitational dance would fling it into exactly the kind of distant, tilted orbit that Planet 9 follows today. This scenario explains several mysteries that have long puzzled astronomers. First, it explains why Planet 9 orbits so far from the Sun. Objects that form in our solar system should orbit closer to home because there was more material to build from. But a captured planet could easily end up in the outer reaches, where Planet 9 is hiding. Second, it explains Planet 9's tilted orbit. Planets that form naturally around a star tend to orbit in the same plane, like records spinning on a turntable, but a captured planet would retain a memory of the original orbital plane around its birth star, creating the tilted path we predict for Planet 9. The rogue planet theory also explains why Planet 9 appears to be a mini-Neptune rather than a rocky super-Earth. Mini-Neptunes are incredibly common around other stars. In fact, they're the most abundant type of planet in the galaxy. Our solar system is weird for not having any mini-Neptunes between Earth and Neptune. Planet 9 might be filling that gap with a world it stole from somewhere else. Think of Planet 9 as a cosmic immigrant, carrying the chemical fingerprints of another star system. If we ever find it and study its composition, we might discover elements and isotope ratios that don't match the rest of our solar system. This would be like finding someone with a foreign accent in your hometown, clear evidence of distant origins. The capture process wasn't gentle. Planet 9 would have been yanked away from its birth star with tremendous violence, probably losing any moons it might have had. It would have tumbled through space for millions of years before settling into its current orbit around our sun. But the rogue planet theory faces one major challenge. Capturing a planet is incredibly difficult. The gravitational dance has to be perfectly choreographed with precise speeds and angles. Most close encounters between star systems result in planets being ejected into interstellar space rather than captured. Recent studies suggest that only about 1 in 1,000 close encounters results in successful planet capture. This makes Planet 9 either incredibly lucky or evidence that the early solar system experienced more stellar encounters than we previously thought. Either way, Planet 9 might be our solar system's most exotic immigrant, a world that traveled between the stars before calling our sun home. But there's an even stranger possibility lurking in the shadows. Is Planet 9 really a planet? While most astronomers focus their telescopes on finding a massive world beyond Neptune, a few maverick scientists are exploring these possibilities that seem like science fiction. The gravitational evidence is solid. Something with significant mass is influencing the outer solar system, but that something might be far stranger than a conventional planet. The primordial black hole theory turns the search for Planet 9 into a hunt for one of the universe's most exotic objects. These aren't the monster black holes that swallow stars and entire solar systems. Primordial black holes are microscopic remnants from the universe's violent birth, compressed to densities that defy imagination. A primordial black hole with the mass of 10 Earths would be smaller than a bowling ball, yet it would warp spacetime exactly as Planet 9 is predicted to do. It would shepherd distant objects with the same gravitational precision, creating the same clustering patterns that convinced astronomers a ninth planet exists. The idea isn't as crazy as it sounds. Cosmologists believe primordial black holes formed during the first fraction of a second after the Big Bang, when density fluctuations in the early universe collapsed under their own gravity. These ancient relics could be scattered throughout the galaxy, invisible until their gravitational effects give them away. Finding a primordial black hole would be nearly impossible with current technology. Unlike planets, black holes don't reflect light, they don't emit heat, they're essentially invisible, except for their gravitational effects. The only way to detect one would be to notice its effects on nearby objects, exactly what we're seeing in the outer solar system. But the primordial black hole theory faces serious challenges. These objects are extremely rare, and the odds of one being captured by our solar system are astronomically small. It would be like winning the cosmic lottery with a ticket you didn't know you bought. The dark matter hypothesis offers an even more exotic explanation. What if the gravitational effects attributed to Planet 9 are actually caused by a concentration of dark matter, the mysterious substance that makes up most of the universe's mass but only interacts through gravity? Dark matter normally spreads itself thinly throughout space, invisible and undetectable, except through its gravitational effects on visible matter.
But under certain conditions, dark matter can clump together into dense halos that behave like massive objects. A dark matter halo with the mass of a few Earths could theoretically produce the same gravitational shepherding effects as Planet 9. The appeal of the dark matter theory is that it explains why Planet 9 has been so difficult to find. Dark matter doesn't emit or reflect light, making it completely invisible to telescopes. It would be the ultimate cosmic hide-and-seek champion, with enormous gravitational influence but zero visibility. Some scientists have proposed even more exotic alternatives. Could the gravitational anomalies be caused by modifications to Einstein's theory of gravity that only become apparent at extreme distances? Or could they result from interactions with extra dimensions that exist beyond our normal three-dimensional space? These alternative theories share one common problem. Testing them with current technology is nearly impossible. Unlike a conventional planet that would eventually show up in powerful enough telescopes, primordial black holes and dark matter concentrations remain stubbornly invisible. The scientific community remains largely skeptical of these exotic alternatives, not because they're impossible, but because they require invoking rare and poorly understood phenomena to explain what a conventional planet explains perfectly. But until someone actually finds Planet 9, these alternative explanations continue to lurk in the shadows of possibility. Meanwhile, the search was about to become a high-tech treasure hunt involving the most powerful telescopes on Earth.
Technology revolution.
Finding Planet 9 has become the ultimate test of human ingenuity and technological precision. From the volcanic peaks of Hawaii to the bone-dry deserts of Chile, the world's most advanced telescopes have turned their electronic eyes toward the outer darkness, each hoping to capture the first photons of light reflected from our solar system's most elusive world. This isn't just astronomy anymore, it's technological warfare against the cosmic dark. The Vera C. Rubin Observatory in Chile represents the most ambitious ground-based survey ever attempted. Starting operations in the mid-2020s, this facility will photograph the entire visible sky every few nights with unprecedented depth and precision. Its giant digital camera will capture images containing over 3 billion pixels, creating a time-lapse movie of the cosmos that reveals everything moving against the background stars. Think of the Rubin Observatory as a cosmic security camera with perfect memory and infinite patience. It will automatically detect and track every moving object brighter than 25th magnitude across the entire southern sky. If Planet 9 is anywhere within its detection limits, the Rubin Observatory will find it within its first few years of operation. The Nancy Grace Roman Space Telescope, launching in the mid-2020s, will extend the search into infrared wavelength, where Planet 9 might be most easily detected. Its position above Earth's atmosphere will provide crystal-clear images, free from the distortions that limit ground-based telescopes. The Roman telescope's infrared sensitivity could detect Planet 9's faint heat glow even at distances where reflected sunlight becomes undetectable. But the most exciting developments might come from unexpected directions. Artificial intelligence algorithms trained on the distinctive signatures of planetary motion are becoming sophisticated enough to identify Planet 9, even in archival images that human analysts missed. These digital archaeologists are excavating decades of astronomical data, looking for faint signals that previous searches overlooked.
The breakthrough might come from gravitational wave detectors, instruments originally designed to detect ripples in space-time from colliding black holes. If Planet 9 has a large moon or binary companion, the orbital motion might create detectable gravitational wave signals that could pinpoint its location without requiring any light at all. Interplanetary spacecraft are becoming sensitive enough to directly measure tiny deviations in their trajectories. The Parker Solar Probe, New Horizons, and Voyager spacecraft all carry instruments capable of measuring small deviations in their orbits. A coordinated analysis of multiple spacecraft paths might triangulate Planet 9's position through gravitational forensics. The James Webb Space Telescope, already revolutionizing our understanding of the early universe, might stumble across Planet 9 while conducting deep infrared surveys. Its incredible sensitivity and resolution could detect Planet 9 as a moving infrared source, distinguishing it from background objects through precise photometry and spectroscopy. Even more futuristic detection methods are being developed. Proposals for gravitational microlensing surveys could detect Planet 9 through its gravitational effects on background starlight. Networks of small robotic telescopes might catch Planet 9 transiting in front of distant stars, revealing its size and orbital characteristics. The convergence of these technologies creates such a comprehensive detection net that Planet 9 would need to be extraordinarily well hidden to avoid discovery much longer. If it exists within the mass and distance ranges predicted by current models, multiple independent detection methods should find it within the next decade. But if Planet 9 remains undetected despite these technological advances, that absence will become just as scientifically significant as a positive detection. The null result would force astronomers to reconsider fundamental assumptions about planet formation, gravitational dynamics, and the architecture of our solar system. The stage is set for the final act in one of astronomy's greatest detective stories. Conclusion: secrets in the darkness. The search for Planet 9 has revealed that our solar system still holds secrets waiting to be discovered in the cosmic dark. From the first mysterious orbital alignments pointing to an invisible puppet master, to the sophisticated computer simulations mapping its gravitational effects, we followed the mathematical trail leading to what might be the most significant planetary discovery since Neptune. The evidence has transformed from curious coincidence to compelling proof that something massive exists, shaping the outer solar system from the shadows. Whether Planet 9 is a super-Earth exiled by gravitational warfare, a rogue world captured from another star, or something even more exotic, its discovery would fundamentally change our understanding of planet formation and solar system evolution. We would learn that our cosmic neighborhood is far more dynamic and violent than we imagined, shaped by forces operating on timescales that dwarf human history. But Planet 9 represents something deeper than just another world to add to our solar system. It embodies the power of human curiosity to detect the invisible, to read gravitational signatures like cosmic fingerprints, and to use mathematics as a tool for exploring the hidden architecture of the universe. The search has pushed telescope technology to its limits, developed new techniques for finding faint objects, and created computer simulations sophisticated enough to fast forward through billions of years of planetary evolution. The search for Planet 9 has also revealed the collaborative nature of modern science, a science where teams around the world share data, compare results, and build on each other's discoveries while competing for the ultimate prize. It shows how statistical analysis can transform astronomical observations into mathematical certainty, and how indirect evidence can be just as compelling as direct detection. Perhaps most remarkably, the search showed that major discoveries about our own solar system are still possible. In an age when Mars rovers analyze alien rocks and space telescopes peer into the earliest moments of cosmic history, we learned that deep mysteries are still hiding in our own cosmic backyard. The outer solar system remains a largely unexplored region where new worlds await discovery. The next decade promises to resolve the Planet 9 mystery one way or another. Advanced telescopes, artificial intelligence algorithms, and revolutionary detection techniques are converging to create capabilities that will either find our hidden ninth planet or definitively prove it doesn't exist. We stand at the threshold of answering one of the most compelling questions in planetary science. But regardless of whether Planet 9 is ultimately found or ruled out, the search has already transformed our understanding of how planetary systems evolve and revealed that our solar system is far stranger and more dynamic than we ever imagined. What other cosmic secrets are lurking in the darkness, waiting for the next generation of planet hunters to uncover them? If you're fascinated by the cosmic detective work that's reshaping our understanding of the solar system, subscribe for more astronomical mysteries and hit that notification bell so you never miss the latest discoveries from the final frontier. Good night.